Welcome to HVS Technologies. Here we are demonstrating BLDC motor drive based on Bridgeless Landsman power factor converter. So in this project, this is the totally circuits called as Bridgeless Landsman power factor converter circuit, and is a microcontroller. We are going to control the speed of this BLDC motor. So this BLDC motor of 12 volt 30 amps of rating, and is an electronic speed controller of same 30 amps of ESC. So this ESC consists of 6 MOSFETs interfaced in a bridge circuit model, and these 3 are the connections to the BLDC motor. So from here we give the signal to this BLDC motor to rotating controls with the input speed of setting from this potentiometer, and the LCD will display the PWM signal level which we are giving to the speed controlling purpose, as well as to this Bridgeless Landsman circuit. So what is a Bridgeless? So here we are not going to use any rectifier bridge circuits to convert AC to DC. So for this one we are using this proposed circuit. So in this one we have the two sections for positive and a negative off cycle. So when we are giving the AC signal through this filter circuit, there is a LC filter circuit, inductor and capacitor filter circuit. So for positive off cycle, so as we can see this, the positive signal will be fed to this, and here the diode will not conduct, so it will fed to the circuit, and based on the signal given input from this PWM generator, so we are using this microcontroller as a PWM signal generator and given to this MOSFET. This circuit will on and off, so that parallelly the capacitors and inductors will get charged and discharged. So this is the positive off cycle. Coming to the negative off cycle, so the negative nothing but here will come into the negative, and this diode will conduct in forward direction for negative off cycle. So this circuit will works in same manner for positive off cycle how it works. So like this you can see this, when I have the positive off cycle only these circuits will works, and coming to the negative off cycle only these circuits will work, and continuously will get the current in the output end, and this is given to the this VSI, this voltage source inverter, and this voltage source inverter also controlled by the this microcontroller section. Okay, and here as you can see this how this capacitor charging and discharging is noted in this proposed circuit diagram also. So based on the signal giving from this PWM generator, this Bridgeless Landsman circuit will generate the DC voltage which is of 20 amps of current can stable. It can give the signal to this ESC, so the ESC can stable up to 30 amps. Though we are giving 20 amps, nothing will happen, and this motor will be speed controlled by this input signal from the potentiometer. So in this one you can see this inductor and capacitor filter circuits, and given to this multiple inductors placed in this module, and so based on these capacitors as well as inductors mentioned in the circuit, same will be appear here. So the charging and discharging purpose, and there is a one MOSFET, you can observe that, and another MOSFET we placed here. So these two MOSFETs are connected, and these two are aluminum plates are heat sink to this MOSFET for safety purpose. Whenever the high current is gained by this motor, then the circuit will not get damaged. So let us see the demonstration. Just give the supply to this one. So you can see the welcome message on the LCD. So it will give the beeps. So initially, in order to set for the triggering angle, just rotate this. So you can observe the PWM level changes. So slowly rotate that right. At some point it will catch the firing angle and the motor will start rotating. So you can see the PWM level. Based on the PWM level, parallelly the motor speed will be controlled. So I am increasing the speed now, maximum speed. That's up to 100 of PWM signal level. That's the duty cycle given 100, and I am reducing that. So by connecting these 3 pins in CRO, you can observe the waveforms of VSI output. Right. Thank you for watching demo.